Okay, so we're going to look at how to solve simultaneous equations using the substitution method. There are two methods, substitution method and elimination method. So this video focuses on the substitution method. Substitution method, as listed here, is particularly useful when one or both of the equations is in a form where one of the two variables is the subject. So you can see here, this is what we call the subject. So the y is the subject. That's kind of a good hint that this is an example where you'd use the substitution method. This variable is then substituted into the other equation, producing the third equation with only one variable, and we then use this equation to solve the equation. So, worked example 4 from your textbook. If we write out the two equations, we always call the equations something, so I'm going to call it equation 1 and equation 2. I can substitute, and the setting out and what I'm about to write, that's actually crucial, these steps that you write. We're going to substitute 2x minus 1 instead of, or for y, in equation 2. So what that means, in equation 2, wherever I see y, I'm not going to put y, I'm going to put 2x minus 1. Because, as you can see, it tells us that y is equal to 2x minus 1. So here, what I'm going to put there, instead of y, I'm putting 2x minus 1. And I can do that because they're equal. We're told above that y is equal to 2x minus 1. So I expand my brackets. 4 by 2x is 8x, 4 by minus 1 is minus 4. Combine my like terms. I'll go up here, I haven't left enough space. You can see that what it said here above, this variable is then substituted into the other equation, which is what we did here, producing a third equation with only one variable. We've only got one variable now. So we then use our knowledge of our equations. I'm going to add 4 to this side. So 11x is 33. I'm going to divide by 11. So x is 3. So we're halfway there. We've found x. What we then do is we substitute 3 instead of x. And you can choose which equation you do it in. I'm going to choose it in 1 because I think that looks easier. So I write out equation 1. And what I'm going to do, where I see x, I'm going to put 3. Because we found that x is 3. So y is equal to 2. I'm not going to put x, I'm going to put 3. So y is equal to 6 minus 1. So y is equal to 5. So to solve this, we must write so, or the answer is, so x is 3, y equals 5. So in other words, those two equations work, cross if they were graphed when x is 3 and y is 5. Alright, let's look at another worked example. Here is equation 1. Here is equation 2. In both cases, it's y is equal to something. So we can say that 5x minus 8 must be equal to minus 3x plus 16 because both of these things are equal to y. If they're both equal to y, they both must be equal to each other. So rearranging our equations, I'm going to add 8 to this side. So 5x equals negative 3x plus 24. Bringing the x's together means moving this over to the left-hand side and we add it. So 8x is 24. Divide by 8. So x is 3. Again, we're halfway through. So we can substitute 3 instead of x, and you can choose in equation 1 or equation 2. I'm going to again choose equation 1 because I think it looks easier. So equation 1 was y equals 5x minus 8, but I'm going to put, instead of x, I'm putting 3. So y equals 15 minus 8, so y is equal to 7. So the solution is x is 3 and y equals 7. So those two examples are examples of substitution method. Probably really good to read again here, straight from your textbook though, of when to use the substitution method and these two slightly different types of substitution method.